Hi children, we continue with our chapter, fourth chapter, carbon and its compounds, and our topic for today is a very important topic, functional groups. Functional group. So, in the beginning of the chapter, when we discussed versatile nature of carbon, there was a topic called tetravalency. One of the reasons for the versatile nature of carbon is its tetravalency. Valency of carbon is 4 and it is capable of forming 4 bonds with either other atoms of carbon or atoms of non-metals such as hydrogen, oxygen, sulfur, nitrogen, etc. Isn't it? So, carbon is capable of forming bonds with other atoms of other non-metals like not only hydrogen but other non-metals like halogens. Halogens are a group of non-metals, fluorine, chlorine, bromine, iodine, etc. All these come under halogens. So, carbon can form bonds with halogens, then oxygen, sulfur, nitrogen, etc. So, carbon is capable of forming bonds not only with hydrogen, but it can form bonds with atoms of halogens like fluorine, chlorine, bromine, iodine, etc. Then oxygen, nitrogen, sulfur, etc. Okay, so carbon can form bonds with other atoms of other non-metals. So, consider a hydrocarbon, simplest hydrocarbon. The carbon forms 4 bonds with hydrogen atoms. This is a hydrocarbon, compound between carbon and hydrogen, where all the bonds are formed between carbon and hydrogen. Name of this compound is methane. In a hydrocarbon chain, one or more hydrogens can be replaced by atoms of other elements. One or more hydrogens can be replaced by atoms of other elements. So, this hydrogen can be replaced and it can be occupied by a chlorine atom. Now, it is no more methane. One of the hydrogen is replaced by a chlorine atom. We call it as chloromethane. It is a new compound with an entirely new set of properties, chloromethane. Similarly, the second hydrogen can be removed and we call it as, now 2 hydrogen atoms, 2 chlorine atoms, we call it as dichloromethane. It is known as dichloromethane. Now, the third hydrogen can be replaced by chlorine atom, then it is called trichloromethane. New compound with new properties. The last one also can be removed. Then we call it as tetrachloromethane or carbon tetrachlorine. All the hydrogens in this hydrocarbon chain are replaced by atoms of other non-metal like chlorine here. Okay. So, in a hydrocarbon chain, one or more hydrogens can be replaced by atoms of other non-metals. And in such a compound, the atom that replaces, the element that replaces hydrogen atom, they are known as heteroatom. The atom that replaces a hydrogen, that is known as a heteroatom. So, in a hydrocarbon chain other than carbon and hydrogen, if any other element is present, we call it as a heteroatom. Okay. And when the hydrogen is replaced by this heteroatom, actually what happened? It results in the formation of a new compound and there is change in property, change in reactivity, everything is new and we have a new compound with new set of properties. Okay. So, heteroatom is nothing but the element that replaces hydrogen in the hydrocarbon chain. Now, what is a functional group? Now, in this compound, this chlorine atom acts as a functional group. We write it as an atom. Functional group is an atom or a group of atoms. An atom or a group of atoms that make a carbon compound reactive and decides its properties. An atom or a group of atoms which makes a carbon compound reactive and decides its properties is known as a functional group. An atom or a group of atoms which make a carbon compound reactive and decides its properties is known as a functional group. Now, here this chlorine is a functional group. It is an atom. It makes the carbon compound reactive and decides its properties. So, this is chloromethane. One of the hydrogen atom is replaced by chlorine. We call it as chloromethane. Here the heteroatom is chlorine and it acts as a functional group here. It is an atom which makes this compound reactive and decides its properties. But sometimes this functional group will exist as a group of atoms. Now, here there is only a single atom, but it can be a group of atoms. That is also known as a functional group. So, we will see more examples of functional atom. Functional group. So, heteroatom, functional group, then the formula of the functional group also we have to learn. Formula of the functional group. It's very important. So, heteroatom, halogen, chlorine, bromine and chlorine we will take. Then the functional group is chloro or bromo. We call it as either chloro or bromo compound. We call the compound with one hydrogen replaced by chlorine as chloromethane. Then the functional group is chloro. And the formula of the functional group is, what is this line represent? This line is actually the bond which attach this group, functional group, to the carbon chain. This is actually the bond that is connected to the carbon atom. That is why we have to write the line. Now, heteroatom, oxygen. With the heteroatom oxygen, we have several functional groups. The first one is alcohol. Alcohol is written as OH. If you see an OH group, this is a group of atoms. Heteroatom is oxygen, but oxygen together with a hydrogen exists as alcohol. Okay, so this is OH. Now B, aldehyde. Next one is aldehyde, which exists as CHO, and oxygen in combination with a carbon and hydrogen, and it can be written like, this is the formula actually, CHO. Simply you can write it as CHO, but to see how the valency criterion is maintained here, this is how the detailed structure of the functional group. See, this O is C double bond O, so that all the valencies of carbon are occupied. This is the bond which connects this functional group to the carbon chain. Then a double bond, so 3. One is to a hydrogen, so it is 4 valency. All the 4 valencies are satisfied. CHO. Next one is ketone. It is written as CO, but the formula is C double bond O, again a bond. So, this functional group always come in the middle of a hydrocarbon chain only, not at the end, in the middle of a hydrocarbon chain. All the valencies of carbon, this valency will be attached to one carbon atom, this single valency will be attached to another carbon atom, and the bond with the oxygen is double bond. Oxygen has valency 2, so it forms a double bond here with oxygen, so carbon. Next one is carboxylic acid. COOH. We have seen these type of compounds. CH3COOH. We have written it as acetic acid, a weak acid, acetic acid. So, this is a carboxylic acid group. C double bond O, then OH. This is how the carboxylic acid group exists. All these are fixed, you have to by heart it. Okay. So, these are the functional groups that you have to learn. One is halogen. Under halogens we have to learn only chlorine and bromine. We call it as chloro or bromo, and this is the formula. One bond connecting to chlorine and bromine. Then with oxygen as the heteroatom, we have 4 functional groups: alcohol with the formula OH, aldehyde with the formula CHO, ketone with the formula CO, and carboxylic acid with the formula COOH. Everywhere the heteroatom is oxygen. Other atoms are carbon and hydrogen. They are not heteroatoms, but it exists as a group. They exist as a group of atoms. So, group of atoms that make a compound reactive and decides the property. So, that is a functional group. Together we call it as a functional group. And the formula of each functional group you have to learn. Aldehyde is written as C double bond O H. Ketone is written as C double bond O. Carboxylic acid is written as C double bond O OH. Next is nomenclature or naming of carbon compounds. Nomenclature or naming of carbon compounds. And naming a carbon compound, nomenclature is the meaning of nomenclature is naming. I think this you have learned in biology. So, naming a carbon compound can be done by this following method. First one is identify the number of carbon atoms. First you count the number of carbon atoms in the given compounds. Then find the word root. Word root we have already learned. If the number of carbon atom is 1, we write it as meth, 2, eth, prop, but, like that. So, count the number of carbon atoms in the given compound, then select the appropriate word root depending upon the number of carbon atoms. Second one is identify the compound as an alkane, alkene or alkyne. Identify the compound as an alkane, alkene or alkyne. How do you identify the compound as alkane, alkene or alkyne? Look at the bond between the carbon atom, not between carbon and oxygen. Look at the bond between carbon atom. If all the bonds between carbons, I repeat, between carbons, if all the bonds between carbon atoms are single bonds, it is an alkane. So, along with the word root, if the word root, you have 3 carbons in the chain, word root obtained is prop. So, if all the bonds are single bonds, you will write it as propane, propane. It is a compound of propane. If any of the bond is a double bond, it is an alkene. If any bond is a triple bond, between carbon atom, if any of the bond is a triple bond, we call it as alkyne. So, along with the word root, ane, ene or yne, you have to add. So, we will do lot of examples, then you will understand it better. Then the third step is identify the functional group, if any. Identify whether any functional group is present in the carbon compound, whether it has a functional group. It has to be indicated in the name of the compound as prefix or suffix. So, we have different prefix or suffix to be added for each functional group. That table I will give you. So, identify the functional group. If any functional group is present, identify it and it should be indicated in the name of the compound as a prefix or suffix. And the last one is, if it is a prefix, suffix, in case of suffix, delete the final E, alkane, alkene or alkane, propane, propene, propine, whatever it is, final E should be deleted. Delete the final E and in place appropriate suffix has to be added. Appropriate suffix to be added in the place of that final E. So, in case of suffix, delete the final E from the name of the compound and add the appropriate suffix. So, now we will see what are the suffix and prefix to be added. So, chloro or bromo, Cl or Br, if it is present in the compound, we have to add a prefix only, not suffix. Prefix chloro or bromo to be added to the name of the compound, bromo or chloro to be added. Now, alcohol. So, if an OH group is present in the compound, it is an alcohol, it is suffix OL. Final E should be deleted from the name of the compound. Final E should be deleted from the name of the compound and you have to add the suffix OL. Now aldehyde, that is if you have a CHO functional group, again suffix AL, al, to be added to the name of the compound. Final E has to be deleted and you have to add the suffix AL. Then ketone, CO is present, again suffix ONE, on. E should be deleted and you have to add on. And the last one is carboxylic acid. Let us see what is the suffix to be added. Carboxylic acid, COOH group. Again suffix to be added and it is oic acid. Final E should be deleted and we add the suffix oic acid. So for chlorine and bromine it is prefix chloro or bromo. Alcohol it is suffix OL. Aldehyde suffix AL. Ketone suffix ONE. And carboxylic acid suffix oic acid. Okay. Now let us do one example. Then you will understand it better. Consider this compound. Consider this compound. We will follow the different steps to be followed for nomenclature. First step is identify the number of carbon atoms in the compound and select the word root. Identify the number of carbon atoms and select the word root. How many carbon atoms are there? 3. So the word root to be added is prop. For 3 carbon the word root is prop. Now second step is identify the compound as an alkane, alkene or alkyne. So for that, look at the nature of the bond between carbon atom. Between the carbon atom, all the bonds are single bonds. So we add ANE. So it's a compound of propane, alkane. All the bonds are single bonds. So we write it as propane. Now third step, identify the functional group. Here there is a functional group. A chlorine atom is present as a functional group. So its name has to be indicated as prefix or suffix in the compound. Chlorine, as we have seen in the previous table, chlorine, if a chlorine atom, chloro is present, it is a prefix only. So you have to add the prefix chloro. So it's over. Chloropropane. Name of the compound is chloropropane. Okay. Now another compound I will write. Another compound I will write. Okay. How many carbon atoms are? First step is identifying the number of carbon atoms. 1, 2, 3, 4. So the word root is but. Isn't it? 4 carbon atoms. So the word root is but. Look at the nature of the bonds between carbons. All the bonds are single bonds. So we write ANE. It's an alkane, butane. Now there is a functional group present. OH. OH is the alcohol group. So it is not prefix, we have to add the suffix. It comes as a suffix. Which is a suffix for alcohol? It is OL, all. How is this OL added? All added by deleting the final E. Delete the final E from butane and in place of E you add OL, butanol, making its name butanol. Now I hope you understood. More examples we will do in the next class. This is an important topic, you have to learn it well. Then only you will understand the concepts that we are going to learn in the coming classes. Okay? Thank you children.